19, if 36,800 is deposited into an account and earns 4.9% interest compounded continuously. Okay, so here's where it changes, and this one is the PERT formula because it's continuously. So just keep that in mind. Don't forget. Continuously is basically doing this many times. Like, I mean, you could consider it billions of times, but it basically forms a limit to one number, and it's called E. Okay, so our principal value here is 36,800, and we're gonna take the E, so that's second ln. Second ln provides our E with the superscript, and we're going to raise that to 0.049. So we still move the decimal place over twice to get that decimal. It is increasing, so it will be a positive rate, and we're going to multiply that by 5 because that's what our formula calls for. And as long as it makes sense to you, I mean, always fact check reality. Does $47,016.46 make sense for 5 years at almost 5%? Hopefully it does. It should. That's reasonable. It's pretty good actually, because it's 5%. It's pretty good. All right. So next, this is the same type of question, but now how long? Okay, we have to find out a next value. That's where the tables come in. Okay, we don't know how to do this algebraically so that we could step away from this. We have to go to the tables to tell us where that value is going to be. So we're going to go ahead and go to y equals. We're going to clear that out. We're going to go 3300. Now notice if I want tables, I go to the y equals button because that's going to do all the calculations for me. And so I just need to scale in the table where exactly I belong. All right, so 3,300 compounded continuously for point. Am I at the right one? 0.4. I feel like I already did point. Oh, did I do? Shoot. 0.49. That was, yeah. Okay, good. All right, we're good. So 0.4046. Okay, and we're going to put the x up there. Okay, because I don't know how long I'm going to have it calculated for me. So now I'm going to go to my table, but I'm going to go table set. I'm going to actually start at 1, and I'm going to go up by 1. And then if I need to change that, I'll do so. But just remember, we started in many different places, many different times already just this evening, and I want to find out when it equals 16,000. So I could keep scrolling. I just feel like I'm going to start at like 25. Okay, there we go. So 16,900. All right, 16,000 is between 35 and 36. So let's go to 35, and now I'm going to go up 0.1. Go back to my table, and 16.9 is between 35 and 35.5 and 35.6. So my guess, it's not a guess actually, it's going to be 35.55. 35.55. Yep, okay. So round to the nearest tenth, so that would be the 6th. Alright, and that is how many years? Well, is that right? Years? Yeah, compounded continuously, so that's years. Alright, so 35 years. Yep, it's a long time because 4.6%, and you're just not going to touch it, and for it to equal that amount, it's got to be quite a while. Alright, 21. Now this, how long would it take to double? Now these are 3 different types of problems, right? This you plug and chug. This one use a table, but I'm sorry, this one's plug and chug, use a table. This one is actually a little different. This is actually when does it double? So here's the thing. What you want to do is just think, do I have a starting point? And if you don't have a starting point, then you want to give it one. Like just say $100. Find out how long it takes to get to 200. This one, you start off with 3,100. how long does it take to get 6,200? All right, so really number 20 and 21 are the same. I'm going to go ahead and redraw my model here, 3,100. Compounded continuously, so I grab my e to the x, so I'm in my superscript, and I see that I got 3.5%. That's 0.035, and I don't know how long. I want to have all kinds of variety there, so I put an x. So how long would it take to double? I'm looking for 6,200 now, right? I want this to become 6,200 because that is precisely double that amount. So I don't know where to start my table, so I'm going to go to table set, maybe 10. I don't know. Let's see. Oh, I'm going up by tenths. It's going to take forever there. Let's go up by 10.2. Well, I don't want to do that. It's solid 10. Go up by 1. What is it, 6,200? Okay, we're good. Between 19 and 20. 19 and 20. So let's zoom in. Let's go to table set, 19. I'm going to go up by 0.1. All right, did it say round to the nearest tenth? Yep, so 19. And we're at 62, so right there. So right there, 19.8. So 19.8 years. Okay, so let me just... Oh yeah, okay. There's called the rule of 69. If you're compounding continuously, if you just take the number 69 and divide by 3.5, you can actually find out when your doubling rate is. It's a cool little rule. We didn't talk about it too much. You'll talk about it more in pre-calc, but it's a pretty neat little rule called the rule of 69, and it tells you when you can double your money. Anyways, that's not on the test. Continuously, man, 22 is just, it's the same thing, you got the same type of equation. You plug in 15, you plug in 30. How much interest was made in the first 15 years? Okay, well, then you find out, you take this and subtract that from, you subtract 3,600 from how much you got, and then here, you subtract how much you got from 30 with how much you got from 15. So it's really kind of simple. We're kind of beating a dead horse here. But for posterity's sake, we will do it. We will commit. We'll do it. Compounded continuously. Second, E. Let's get that 0.053. We're going to multiply by, we're going to go 15. Got to multiply by 15. All right. So we're just going to drop that down. 15 years. And that's 9,9. Okay, after 30 years. Okay, just copy that and right over that. All right, how much interest was made? Well, take that first value and you're going to subtract that from 3,600. Looks like you made $4,371.99. And then what was the difference between these two, right? Between 15 and 30? Well, take the 17 and you're going to subtract the 15. And that's $9,681.51. Okay, so those are the answers. And if this doesn't make sense, pause it, look at what's in the calculator and see how it was calculated. But that's it. We'll stop right there and we'll finish off. Let's see what we got. Yeah, we got some story problems, but you already got the model. So it's like there's really no, oh wait, no, okay, this is super important. I should tell you this like right now. For real, you have to